So for this problem, we have to find the work done by the friction force, which equals the change in the kinetic energy minus the work of the mass, which if we simplify it and further break it down, it's equal to the kinetic energy, V2, and it's the kinetic energy of V final, V initial squared minus 0. Now we know that the V final is 0 because that's when it reaches its maximum height. So basically, it's going to be WF equals half, let's say the mass is 2. You know that V final is 1.1 times 2 minus half. Again, the mass is 2. The initial is VA, which is times 2 squared. So the work of the friction is equal to 1.1 squared minus 2 squared, which equals negative 3.79 joules. For B, we have to find the velocity. So basically the distance, which we're going to call displacement, which is the change in S. Now to find that, we have to again do the net work equals the change in K. Now that net work equals, and we discovered that this would be negative 4. So moving forward, what we have to do is break this down, and this is the mass times gravity, y1 minus y2 minus that the normal force times the displacement of S equals negative 4. That's currently our problem. So what we have here, we know this is the negative force as well. So we can just simplify all the negatives. Along with doing that, we can just go ahead and replace this with the displacement of S, because that's basically what it is. So what we would have is mg displacement of S with the sine of the theta minus, actually we're deleting all the negatives, so plus 0.3 because that's the normal force times mg cosine of theta is the displacement times the displacement of S equals negative 4. So they're simplifying it, and we can factor out the displacement of S. So equals mg sine of 30 is 0.5 plus 0.3 cosine of 30 is 0.87, and that's times mg as well, equals negative 4. So here we have the displacement of S equals 4 divided by 20 times 0.5 plus 6 times 0.87. Now if we further simplify that, that equals 4 over 15.22, which equals 0.26, and that's the displacement of S.